Okay, good afternoon, everyone. Thank you for tuning in to another session of EI Live K-12 for students and educators. My name is Cassie, and I oversee educational and outreach activities at the Earth Institute. For those of you who aren't familiar with the Earth Institute and are joining us for the first time, our core mission is to foster a greater understanding of the science behind climate change and sustainability. And what we as global citizens can do. Experts that make up the Earth Institute are actually all over the place in terms of disciplines, which is fantastic. They include economists, business and policy experts, specialists in public health and law, and of course, earth and environmental scientists. The Institute is made up of about 24 or so different research centers and several hundred people who collaborate across different departments and disciplines at Columbia. What we are aiming to do with these EI Live K-12 sessions is to introduce you to that interdisciplinary work that our wonderful scientists and staff members are doing, and through our experts directly. And we're going to have these weekly sessions until the end of June. If you'd like any more information about upcoming sessions, feel free to contact me directly. Today, we're very lucky to have Jackie Ratner from the National Center for Disaster Preparedness, which is one of those Earth Institute research centers. She's a senior project manager there at the National Center for Disaster Preparedness, and she's going to talk to us all about how to use data to tell stories and the power that we have in using data to tell very, very influential and impactful stories. So we'll turn it over to her. She's going to speak for a little bit, and then we will open it up to Q&A. We're also going to have someone from the NASA Goddard Institute of Space Studies here sharing some relevant NASA data-related resources with us later on. Feel free to use the Q&A box at any point to ask questions. We'll do our best to address everything, and we will make sure that we also have time at the end for questions. So Jackie, if you want to take over and get started.
Great. Thank you so much, Cassie. Hi, everyone. My name is Jackie Ratner. I am a senior project manager at the National Center for Disaster Preparedness. This is one of the centers in the Earth Institute, as Cassie was talking about. We specialize in applied research. So what we do is we sometimes do our own research, or we take research that other people have done, and we specialize in figuring out how to create solutions that help us solve problems from disasters in particular. So what I'm going to be sharing with you today is how we're using an analysis of policy to understand how children in the pandemic can be better supported. So I'm going to go ahead and share my screen with you. All right. So the first question here is, what is a data story? So here is an example of a data story. It's the one that we're going to be looking at closely today. This was built in a tool called Flourish. Flourish is free to use, and it's pretty easy to get started. So if you're, oh, can you see that? You can't see that.
I see your, the how much pandemic aid in billions was allocated. And now
oh, that's so strange. It I'm apologies.
No problem. Yeah. There we go.
Green box around it went away. Okay. Oh, I guess because it's recording. Sorry about that. Thank you. So we're going to be taking a closer look at this data story today, understanding what makes it a data story and how do we get there. But I want to talk to you first about all the different, so a data story basically is taking numbers and other kinds of data and allowing us to create some sort of message out of it. So numbers on their own are statistics, and statistics can be powerful, but it's more powerful when you thread it together with some kind of narrative. So if we can understand the experience of the people or the location, whatever it is that our numbers are expressing, that gives us a much better sense about what we can do with this data. So statistics on their own don't necessarily tell us what to think or what to do. But if we thread them together, we use data to thread it together into a story, it can be a lot more impactful. So a data story is taking that kind of information. Usually it's presenting it in a visual way, not necessarily always. And we're trying to have some sort of underlying message that the viewer or the reader can walk away with. So here, this data visualization, which is the graphic right here in the middle, is the core of this data story. So this data story is focused on just one data visualization and walking us through how to understand and read this data visualization. You can create a data story or a data visualization out of so many different kinds of data. So this is an example, a gallery from a group that I've been involved in since last year, the DAT Artathon. So it's a combination of data and art. And the goal is to try and use data to create these really compelling stories. So you can see here, this data visualization by Haley is about the refugees who have been displaced in the Levant region, and understanding the impact of this particular earthquake that happened. Here we see an animated data visualization about Himalayan glacial cover and how the glaciers in the Himalayas are shrinking from 2004 to 2018. So what Hannah was able to do was she was able to take two different sets of data, lay them on top of each other, and then animate it. That's more powerful than looking at them side by side. I think you'll agree. Here we have a very art-heavy data visualization by Yolanda, looking at different kinds of risk and different kinds of hazards, conceptualizing it as animals in a zoo, and then creating a zoo out of it. So there's a lot of design that's gone into these. All right. So here, what are we doing in this data story? In this particular data story, our question that we're trying to answer is, how much pandemic aid in billions of dollars was allocated to the top 5 needs of children? And, you know, the parenthetical there that we're not saying is, and what are we supposed to do about that? This is part of a much larger project of policy issue briefs that have come out of the National Center for Disaster Preparedness as part of its Resilient Children, Resilient Communities initiative. You can find that on rcrctoolbox.org. So this is the big question here that we're going to try and answer. And so in this story, we create a narrative as we start to go through this data visualization and we take a closer look at certain pieces of it. So that's pretty cool. It's really impactful that we're able to take a much closer look at some of these amounts here. So if we wanted to see how much childcare was supported by the most recent legislative package, we can pull that piece out. And not only that, but we can see it in relation to everything as a whole and the other key issues as well. If we wanted to see food security was supported in a much smaller amount this time around. But the bigger picture coming from the issue briefs as a whole is that food security had a lot of support in the earlier legislation in the CARES Act. We also look at housing, mental health, and we take a closer look at what aspects of government appropriations go to programs that partially benefit children and which ones go to programs that are specifically designed to benefit children. So where do we even start with something like this? Where do we start with something that's this complicated? Well, the primary source, so in this place, getting it straight from the horse's mouth, the original location of this information is in legislation. That is, for this type of data story, that is where the data is coming from, the numbers and the information that we're interested in looking at. This is a 628-page piece of legislation. Not all legislation is this big, but pandemic aid is very complicated. And this particular policy package was very complicated. So as you go through, you can start to see that they have all of these different programs. So we see education programs here, we see childcare programs down here. And so what you can do, if you were so inclined, is read through all of the legislation. And you could go ahead and try and find the specific dollar amounts in each section. So for instance, $500 million here. And then you would keep going down and you say, okay, we have $2.5 million here. Or if that's too much, and for most people it would be, you try and find a trusted secondary source. So a secondary source of data is pre-digested for you. So this is from a subscription service by Politico. Politico is a news-based publication, news-based journalism. This is from Politico Pro, which is their subscription service. So this is a Highly trusted, very reliable source of political information. So these people have already gone through the bill. They've looked at all of the different subsections and they've pulled out all of these specific amounts that we're interested in. So in this case, our secondary source is really helpful. I also used another secondary source so that I could cross-reference that information. And then anywhere that that information didn't agree with each other, I go back to the primary source just to double check. So it's really important when we're looking at secondary sources for data that they're very trusted, they're very reliable, but also that we can verify the information in it. And the way that I did that was by having a secondary source. All right, so what do we do with all this information once we have it? Well, we call this our raw data. We haven't done anything to it yet. At this point, we are just collecting it. So you'll see here, the program that I'm using is Excel. It allows you to create a spreadsheet and a workbook. I put down what I'm working on, and then I put down the sources that I use. And then I start to build my data table. So the data table is like the skeleton that the entire data story is built around. We have two different kinds of data in this particular data table. There's so many different kinds of data. It's not always just about numbers. Here we have these where you see words, essentially. This is called categorical data. And then we also have our numerical data, which in this case is in dollar amounts. So our first category is the source. Where is the money, which department at the federal level is the money going to be flying into? Then the second piece is the program. So where is it going to be coming out of? Where is it getting distributed to? Based on what that program is and what we know that program does, we can start to make a decision about whether that dollar amount that went into that program is going to be specifically to the benefit of children, partially for the benefit of children, or not at all for the benefit of children. So for instance, something like a university, it's not helping children, it's helping education, but at a higher level. And then we have just a lot of other stuff here. You can see this is not a huge data set. When we talk about something called big data, that's thousands, if not millions of different data points. Here we just have in the hundreds, which is a relatively small-ish data set. So we've got our four kinds of categorical data: our source, our program, the category of whether it is or isn't for children, and then which child issue bucket it's going to go into. So frequently when we talk about policy dollars, we talk about them going into buckets. I don't know why we call it a bucket. It's just what we call it. So we have our 5 buckets here. And so here they're sorted alphabetically: broadband, childcare, education, which is related to broadband, food security, housing, mental health. So for each of these, basically what we're trying to do is we're trying to collect this information. Which pieces of this data came directly from our source, from our primary source? We get the department, we get the program, we get the total amount, but the rest of this wasn't in there. The rest of this wasn't in that primary source. So if we're talking about just the raw data, it would be these 3 columns alone. You could make data visualizations out of that, and I'm sure it would be very interesting. But for our purposes, to tell the story, we need to do something more with it. What we need to do is we need to say how it's going to affect kids. So we start to analyze this data. So we start to say, is this program for the benefit of kids or not for the benefit of kids? Then we say, okay, well, if it is, how much of that money do we think is going to help kids in the long run? So if it's a program like Head Start, which is a preschool program specifically for kids, then we assume that it's 100% of that amount. Now, if it's partially for, it gets a little bit trickier. And that's where some of this analysis starts to come into play. So our raw data is these first 3 columns. Then we have our analyzed data, which is our next 3 columns. Whew, that's a lot, right? It is a lot. Collecting data is probably one of the most intensive parts of creating your data story. Collecting your data, cleaning your data. Cleaning essentially means getting rid of anything that's not relevant, making sure that you're trusting your data sources, making it as tidy as you can. So this is a pretty tidy data table. It's already been cleaned. Then we have to go through another step, and we have to format it to go into our data visualization. So in this tool called Flourish, what we're making is a Sankey diagram. It's a particular type of diagram that shows flow. So we're showing how the dollars are flowing from one program all the way to the end, which is the child's issue that we care about. We call these in a Sankey diagram, we call them steps. So the first step, let's go back over to here. So the first step is, here we go, here. Here's 0. 0 is where our program is, and then 0 is where our department is, and 1 is where our program is. So we're stepping here from 0 to 1, and all the way down this entire column here that you're seeing. This is all 0 to 1. The next is going to be from 1 to 2. So 1 to 2 is going from program to if it's specifically or partially for children. What we do to minimize the complication here is we let everything that doesn't involve kids, we let it drop off after step 1. So we're not interested anymore in coronavirus related things that go to research or testing because it's not for kids and it complicates our diagram too much. So this is step 1 to step 2. And then we have step 2 to step 3. So 3 is our last step here. So you might look at this and you might wonder, well, where are steps 2 and 3? For this particular graphic, they're all the way down here. So it all has to go straight down in these columns. That's the way that this particular program likes to read it. So we have to take our nice, easy to read table, and then we have to format it differently, something like this, so that our program can actually read it and create the data visualization. So on the back end, so here's what it looks like when we're working inside of Flourish. So this is our preview of our graphic. Now the back end, so this should look very familiar because we just looked at it in Excel. So here we have our source, the destination. So where's it going? It's not always, well, it depends. Let's get this sorted if we can. It put 0 at the bottom, but that's okay. So essentially, because in step 1 to step 2, so here, step 1 is the program that we care about. Step 2, column E, is the destination, which in this case is whether it's partially or specifically for children. And then how big that line is the value. So that's how we get, so we were just looking at something like this. Step 1 to step 2 on the right, and then the value tells us how big, how thick that line is going to be. So a thicker line tells us it's a bigger dollar amount. So visually, it's helping to communicate that. So once you have all of your data in here, you can start to move it around and get different things that look a little bit different. You can start to play around inside of Flourish. You have a couple of different options here for changing the appearance of your graphic. So here we see what figure we want to use. There's a small difference between an alluvial and a Sankey, which isn't super important for this particular data set. We can change how wide things are. So for instance, if we wanted to make it a little bit chunkier, we could change that and it would change that for us. We could decide that we want to create more space inside of everything. But the problem is that our data here, it's very complicated. So we have to minimize the space and cluster it all together if we want to be able to see all of it. We can change our labels. We can change the colors. We can change the fonts. We can change the way that it animates when we load it up. But ultimately, these are all just aesthetic changes. The colors, I'm sure that's something people are interested in. I know that's one of my favorite parts of data visualization is how do we use colors? Here, I've chosen to override all of the colors because we have specific colors for this project that we like to use. The way that I use color here is if anything is specifically for children, it's in red. If anything is partially for children, it's in blue. And I bet there's a couple people out there who understand their color theory, who maybe take some art classes. So you can guess what purple means. Purple means some of it is partially for kids, some of it came from specifically for kids. So we see purple on the end here. So education, a little bit of dollar amounts came from programs that partially benefit children, but most of it came from programs that specifically benefit children. Childcare is different. Childcare is only for kids. So those programs all specifically go straight through to childcare. And something like broadband, it's really hard to click on because it's so little. There are no child-specific broadband programs. So the only money that comes into broadband is for all of us to share. And so kids are just one part of that. So ultimately we see that it's a smaller amount. So then we tell a story with it. Skip over to one of my favorite parts of the story here. So we look at the childcare industry, we look at education. These are huge amounts. In this figure, we've zoomed in. So that's the same data, but we've zoomed all the way in just to the part of the figure that we really care about. So we've taken a much closer look at education. It's this huge chunk here. Childcare is this other really big chunk. What's the rest of this stuff that's affecting kids? We say, well, it's less than 2%. So we have all these other issues: food security, housing security, mental health care, and less than 2% of all of the money that helps kids went to those issues. So 98% of it went to education and childcare. And so what we find that mental health is really poorly funded. And so why is this so important? It's so important because in disasters, we find that people's mental health becomes a much bigger concern than it was before the disaster. It's a hard time. I think we've all been hearing this a lot. In the pandemic, we're all having a really hard time. And so our funding levels need to reflect that. But instead, we're going actually backwards. So most recently this March, we allocated about $200 million to children's mental health overall, which is about half of what was spent in December. So we're going down when we need to be going up. That's something that a data story can tell us. A data story can tell us, how is this data changing over time and what's the impact of that going to be? So the impact is that we don't actually have enough funding to cover the needs and the ongoing care of the roughly 10 million kids who might need some assistance. Something else that we can look at is we can look at food security. So food security means that people have enough food to eat, that it's healthy food, that they want to be eating as well. So, it's not really food security if all you have is canned beans, because it's not going to keep you healthy and you also don't want to eat it. So food security means you have enough food, but you also have the right kinds of food. And what we're finding is that food insecurity is increasing. So we have fewer and fewer households during the course of a disaster who have enough food, but our food security funding starts to decline before the end of the disaster. So it might not be enough to help all of the households that are struggling to have enough food. And we see something similar with housing programs, but that one's a little bit different because all of this money is going into government programs. And we have something like the stimulus checks, which went direct to individuals. And that's not accounted for in this graphic because this graphic is only looking at government programs. So if we wanted to look at that again as a whole picture, we would see that of the issues facing children, education was the major beneficiary. So about 25% of what we spend on kids goes to education, which is great because it's really important. About 25%, if we include education, goes to kids. Now, if we take that out, because remember, education and childcare together make up 98% of what we spent on kids in March, then it drops to about 8% overall of our funding. So What we can learn from this is we can learn what these differences are. So the differences in spending between these issues. We can understand the differences in spending over time if we compare one policy to another policy. And we can also get a sense of what other things do we consider so important that we have to spend money on. I'm going to go ahead and take a question here. This question is from Lucy. Thank you, Lucy. I think it's interesting too. Lucy wants to know, is there a specific job for designers to construct data stories? Do designers work with scientists directly, or are they data scientists themselves? Lucy, that is a great question. Data science is a rapidly growing field. There is a huge demand for data scientists, and there is a ton of different jobs that you can have in that field. So you can be a designer and work more on the visual side of things. So I'll show you back over here. So something like what Yolanda did here, very artistic representation of the data, more design heavy. You can hear Hannah worked in GIS, Geographic Information Systems. So you can see that one of them is more artistic than the other one. So there's kind of the design end of data science. And then there's the data part of it, kind of in the middle, the people working with the numbers. And then there's the people kind of even before that who can collect data. You can use things like machine learning to help you get large amounts of data. There's people who do database management. So there's a lot of, oh, I'm sorry, that's my dog. So there's a lot of different things that you can do. All right. Do we have any other questions? Oh, there we go. I just figured it out. I'm sorry. That's my dog. Is there enough time to do a demonstration and construct a small data story using Flourish? I love that. I'll ask Adrian. Adrian, do we have enough time? I would need probably a minimum of 5 minutes. What time are we wrapping up?
We have a little bit of time. If possible, maybe we can just pause and let Rosalba share some of her resources. And then if we regroup and do that kind of demo after that, would that be okay?
Yeah, that's great. So Deborah, we're going to do a demonstration. I'll cue it up while Rosalba starts to talk, and then we'll get into it.
Yeah, and I apologize everybody for surprising people with a new face. Cassie unfortunately had to leave the session early. My name is Adrienne. I work in the communications department at the Earth Institute. So for now, anybody, if you keep having questions, keep entering them into the Q&A box, which you should see at the bottom of your Zoom screen. And for now, Rosalba, who is with the NASA Goddard Institute for Space Studies, is joining us. Rosalba, are you there and able to share your resources with the group?
Yes, hello, thank you, Adrienne. Let me try to share my screen. Can you hear me okay?
We can hear you.
Okay. Can you see my screen now?
Yes, I can see your PowerPoint.
Okay. Okay, thank you again. So yes, my name is Rosalba Gerratano. I help support NASA's Office of STEM Engagement at the Goddard Institute for Space Studies, and I am happy to be here to share about some NASA resources. In this case, these resources are very related to visualizing and doing storytelling about Earth science and about climate data. So I want to share with you about Earth Now, Earth Minute, the NASA Earth Observations, or NEO, the Scientific Visualization Studio, SVS, and Worldview. Actually, I'm going to see if I can throw the links in the chat. It is disabled, but if maybe the chat can be enabled, and then I could throw the links to the resources in the chat. And if not, I know that these resources will be posted on the Earth Institute website shortly. So let me go back to the presentation. My mouse is not working. Okay. So the first resource is Earth Now. So this is a 3D app that displays real-time global satellite data about our planet's vital signs. So for example, you can visualize carbon monoxide data or carbon dioxide, ozone, air temperature, soil moisture, and many other measurements. You can access this app on a browser, or you can also download it to Apple or Android devices. So a pretty interactive app to visualize tons of satellite data. The second resource is Earth Minutes. So this is a wide animation series. So it's another way in which scientists let you know about their science, about their data in a very fun way. So as the name implies, each clip is just about a minute, and you can learn about Earth science and about our changing climate. So some of the topics include greenhouse gases, aerosols, clouds, and sea level rise. The next tool that I wanted to share about is NASA Earth Observations, or NEO. So with this tool, you can browse and download imagery of satellite data. We have over 50 different global data sets. So you can download the images in different formats, and they're about many different aspects of Earth science. So again, tons of data from satellites. And another cool thing about NEO is that with each data set, you can access a description of that data set at 3 different levels. So there's a basic one, intermediate, and advanced. So if you're new to Earth science, you can access the basic description and then keep moving on. And it also lets you compare data sets. So you can choose different times. So for example, maybe you want to compare aerosols from 2019 to 2021, things like that. So again, these resources will be posted on the Earth Institute website. There is a tutorial for it, so the link will be on the slide. It is actually pretty easy to use. In just a few steps, you can start analyzing the data and visualizing the data. The next resource is the Scientific Visualization Studio. So this is a compilation of animations and images and kind of like mini documentaries and other visuals that help us understand Earth and space science better. And all these videos and all these animations are free to download. It has literally thousands of visualizations of real satellite data. So I also strongly encourage you to explore this resource. And last but not least, there's also this tool named Worldview. So this one lets you interactively browse over 900 satellite imagery layers. And many of these layers are updated daily and available within 3 hours of observation. So basically you can visualize many different aspects of Earth as it looks right now. I added also the link to the tutorial, so that will also be on the website later. But just to give you an idea, there are again like tons of things that you can access. A lot of data. So for example, there are data sets related to aerosols, drought hazards, floods, and much more. This is an example. So here I was comparing nitrogen dioxide to see how the pandemic has possibly affected air quality in New York. And so one cool thing with Worldview is that you can look and visualize that data and compare also different times. So in this case, I was comparing nitrogen dioxide in New York in January 2021 versus January 2018. And you can, once you have your visual, you can also share it. You can share it on social media, or you can just share the link to, a teacher, a classmate, a friend. So pretty awesome tool that lets you look at Earth as it is pretty much right now. So that's it for me. I just wanted to share that. Thank you for the opportunity.
Great, thank you, Rosalba. And as she mentioned, we will post all of these links on the Earth Institute website, along with the video from this session after we're done. So Jackie, if you want to kind of sign back on, we can do the demo, kind of work through a small data story. And again, anybody that has questions, just kind of keep popping them in the Q&A box and we'll try to answer them as we go.
I think the most recent question from Ming might be for Rosalba. So Rosalba, I don't know if you're there and you can answer in the chat box. I will say that at our center, the National Center for Disaster Preparedness, we don't have internships available at the high school level. Ours start at the undergraduate level, and then we also do graduate student internships. All right, here we go, guys. Let's go ahead and build a data visualization. I think we've got about 7 minutes to do it. All right, so this is what Flourish looks like when you first make your account. It gives you a huge world of opportunities of different kinds of data visualizations that you can make. And then Flourish has its own way of turning that into a storyboard if you want to do it right there in Flourish as well. It's really cool. It's really pretty easy. Obviously, it's not customized, but you can get pretty close. So there's all of these different kinds of data visualizations that you can choose from. So there's map-based ones, there's scatter plots, which are usually really important in science. We use those a lot. We have some nifty things like a 3D map, different kinds of hierarchical data, different ways of showing our data. So we have some things like a photo slider. We have some interactive things. So we have things that move like a bar chart race. We have things specifically for elections. Here we have a parliament chart. There's just so many different kinds of data visualizations. The survey data is really cool too. That one animates as well. They all animate in some way, shape, or form, but some of them are extra cool. So I pulled us together some data here. Oops. I shared the wrong thing. Let's try that again. Here we go. I pulled us together some data here. So this data is about food security in America, starting in April of 2020. So the second month of the pandemic, going up until December of 2020. So the question was, does your family have enough food? And the answers could be yes, yes, but the wrong kind. Sometimes we have enough food. No, we don't have enough food, or they chose not to answer that question. These are the responses. They are in percentage points out of the whole. So you could see, these numbers kind of tell us a story. They kind of say something, right? We see that the yeses went down pretty much 1 point for every month. We see that the yes, but wrong kind also went down, but like, what is that? What does that even mean? So let's go ahead. I'm going to copy this. Let's go ahead and choose a data visualization for it. I am cheating because I already know what I want to do, but this is a big part of the process usually. Oh, that is a great question, Lucy. So how do you choose? There are some great resources out there online that help you understand what kind of data you have and what kind of visualization it would be appropriate for. So I would recommend just kind of Googling that. There's a couple of resources out there written by people who are very passionate about this. Some of them, it's like a little flow chart. So the question is like, is your data numerical? Is it categorical? What are you trying to say with it? What I want to do, so if you look at our data, we have a time series here. So we start in April and we go to December. Then we also have our categorical data over here, yes or no, or sometimes. And then we have our numerical data. So we have 3 different kinds in this data set here. So I want to pick a data visualization that's going to allow us to show all 3 kinds of data. So I am going to choose a bar chart race. What is a bar chart race? Here, Flourish preloads it with an example so you can understand what you're working with. So here we're looking at a bar chart race over the years, but that's not our data, so we're not going to use it. We're just going to delete the whole thing and we're going to go ahead and put ours in instead. So it's already formatted because I already knew that this was what I wanted to do. So I already made sure to match the categories here to the categories on the right here. So if we wanted to choose which columns we were going to visualize. So you can see here that our bar chart race is giving us a little preview in the lower right-hand corner. Actually, our values aren't going all the way out to the Z columns. They are only going to L. And that's probably why the bar chart race paused there for a second. All right, so what does that look like if we want to take a closer look at it? So here we're looking at it. I would change a couple of things here. So for instance, the color, we really don't need it to tell us what the color is. So that legend isn't really something that's adding any extra value. So I would come on over here to the legend and I would turn it off. So now we're looking at this, and maybe there's some other things I would want to change about it. If you wanted to, you could change the colors. Let's say I wanted to overwrite it. So I'll say no is going to be red now. And then that should change. Oh, is it because it's not capitalized? I didn't like that for some reason. Normally that does work. I don't know why it's not working. I have another question here. Great question. So the question is, so if you wanted to customize your data visualizations, what you would have to learn to code. So the question is, what, if you wanted to, is there an advantage to knowing how to code, and then which coding language would be beneficial? The advantage of knowing how to code is you can build pretty much anything you want once you get good enough with it. It means you can build your front end, which is what people are viewing when they're on the web. If I wanted to look at what people are seeing, oh, that's why this isn't working. My computer's having a hard time right now. I'm going to stop my share. You can code your front end, and that gives you a lot more control over how people are viewing the data, how they're interacting with it. If you were going to learn, you can also control better how you're processing your data. This gets more important, the bigger, messier data sets you start to work with. Some of the programming languages, so for making things kind of pretty, Python is a stronger programming language. For doing statistical analysis on your data and being able to make graphics and visualizations, a lot of people use R. There are a ton of different things that you could do with it. It really ultimately depends what your goal is and what end of that spectrum, going from the data collection all the way to the art part of it. There's a whole spectrum there. So it really depends what part of that spectrum you want to focus on. Adrian, are we at time?
Yeah, we're pretty much out of time. If there's anything, is there anything else that you want to share with the group today?
Well, I hope that I've shared kind of my passion for this. I think that data visualization is really fun. I myself haven't gotten into coding. I haven't gotten into the back end and database management. But I think that there's a lot of opportunity across the whole thing, and the things that you can do with data can become really powerful. So it's kind of like you can use data skills regardless of what you want to do. Like if you want to go into, understanding medical issues, you can use data for that. If you want to go into climate change, you can use data for that. If you want to go into helping kids, like I do, you can use data for that too. So this is a skill set that's broadly applicable. And I think that that's something that makes it really exciting to me.
Great, thank you. Well, thank you to Jackie, and thank you to Rosalba, and to everybody who came to watch the session today. Just a thank you in the Q&A. Just a reminder, we'll be having these sessions once a week through the end of June, generally on Thursday afternoons, but there's a couple that are on different days. So please check the calendar if you're interested in joining us for the future, and I hope you are. And if you have any specific questions, please don't hesitate to reach out to Cassie in the meantime. Well, thank you for coming, everybody. We hope to see you next time.